So far, Job. Our next speaker is Job Snyders. He's going to talk about using ARIN WHOIS data in BGP prefix filters.
Hi, I'm Job. Thank you for having me here. I would like to cover with you a particular project that we've been doing in the last few months to make it easier for customers to signal to us, NTT, but also to IX route server operators and other stakeholders what the intentions are of certain IP blocks in terms of routing. Traditionally, we use what is called an IRR, and an IRR is Internet Routing Registry, and it's basically a database where you can publish statements about this IP block should be originated by this ASN. And this is a common source of data, publicly accessible. And the nice thing about it being public is that other people can verify how it works, what data is there, and consume the data in their own prefix filters. If we zoom in on the actual contents of IRR, we have the route object, which is essentially the atom of this concept. And I've highlighted with the bold letters the two elements of the route object that matter. All the other attributes are discarded and not considered by prefix filter generators. There's the prefix itself and the ASN that is allowed to originate the prefix. If we zoom in under the hood, how that data is transformed into actual BGP prefix filters, what happens is certain queries are sent to an IRR daemon. In this instance, the command is !G. It's very intuitive. And the daemon will return you a list of prefixes that can be originated by the ASN for which you did a reverse lookup. So far, so good. Now, in October 2017, I worked together with the Calgary Internet Exchange to migrate them from unfiltered route servers to filtered route servers. The interesting discovery was that after we converted from insecure to secure, there were still 7,000 or so prefixes that were rejected by the filters. And we dug into why are these prefixes rejected? Is this an IRR issue? Is there perhaps any way that we can do a validation step to pump up the number of valid prefixes? And this is where we came across the ARIN WHOIS data source. I recalled from long ago that in the ARIN WHOIS database, which should not be confused with the ARIN IRR database, they are separate, you can document an origin AS. So with the Calgary Internet Exchange data set and the data from ARIN WHOIS database, we saw if there was anything that could be unified or leveraged. And it turned out that from those 7,000 or so invalid prefixes, we could validate an additional 1,700 prefixes using this ARIN WHOIS database. So to us, that meant a 23% reduction in invalid routes. So what is this ARIN WHOIS thing? If you go to the ARIN website and you log in with your My ARIN Online or whatever account, and you go down to where you can manage your net blocks, there's a field called Origin AS. And for each allocation that you received or is managed by ARIN, you can specify one or more origin ASNs. And the beauty of this data source is that it's authoritative, because only the owner of an IP block can actually modify this information. And this places the data source on a higher level of authoritativeness compared to the IRR, where essentially anyone can do anything. And we saw this data actually reflected in the BGP routing tables. If you take the WHOIS data dump, convert it into something your routers can use, you end up with roughly 90,000 let's call it route objects, and 20% of those are a one-to-one match with what we saw in the BGP tables. And for a routing data source, that's a pretty high score. So the mechanics of using the ARIN WHOIS database are a little bit clunky at the moment. I'm hoping that in the coming months this process will be slightly more elegant. But what we do is, and with we I mean NANOG, we download a 3.5 gigabyte XML file that contains all of ARIN WHOIS data, and then we massage that data through a pipeline and only look at objects where there is an actual specification of the origin ASN. Then that reduced data set is converted into IRR format that's shipped off to an IRR daemon, and then the daemon is signaled, hey, load this new database, and that makes it accessible for our tool chain. The reason we did it this way is that NTT would not have to update any of its tool chain regarding the prefix filter generation, and that's always attractive. So the end game in this regard is that customers have a choice. They can either register an IRR route object, or they can specify in ARIN WHOIS what the origin ASN is. And this should make it slightly easier for us to motivate people to indicate what their intentions are. An example could be viewed here. If you issue this command on your terminal, you'll get back what looks like an IRR route object, but in a sense is a reflection of what is originally ARIN WHOIS data from that XML file. The formatting is not entirely ideal. This is what happens when you produce PDFs on OpenBSD. So in this route object, in the remarks, we describe what the actual source is. There's a link to the ARIN WHOIS website where you can see the same data reflected. And the changed date reflects when the original record was created in the ARIN database. I've also loaded this data set into irrexplorer.nlnog.net. You can see on the screen there's various data sources. There's what we see in BGP. There is apparently for the www.arin.net IP address also a route object in the level 3 IRR database. They might want to check that out. There's a route object in the ARIN database, and that's the second last column. We see that there also is a representation in the ARIN WHOIS database. So this is an attempt to make it slightly easier to debug this type of data. There are currently two methods to obtain the data. You can either use what I generate, but I will not claim that that is actually an authoritative data dump, because you just have to trust me on my blue eyes that I correctly did this. So the recommended way to obtain this type of data is to sign the ARIN bulk WHOIS agreement, which is a fairly standard agreement that says don't use this for marketing, don't use it in your commercial products. You sign the agreement, you get an API key, and then you can access the XML file, and then you can throw the XML file through your own pipeline and plug it into your provisioning system. So I will stress again, just go directly to the source. But if you just want to toy around and look at what might be available and might be of use to you, then of course the JSON dump that I provide can be inspected. Well, that's the end of my slide deck. I see two people running to the microphone.
Okay.
The one with the beard can go first.
Well, okay. Well, okay, the one with the longer beard.
30 seconds, because I want to hear both questions.
Yeah, two short remarks. Kind of this morning I heard that the semantics of that field are not defined. That is something that actually should be fixed. The other thing is, of course, also, ARIN should provide what you are doing in transformation, and kind of if there are any problems in understanding how to do this right, I'm offering my services of consultation for free.
Thank you. So I asked ARIN for this type of data dump, and it's on the roadmap, but the timeline, you know I'm very patient. So I was like, come on, I'll just do it myself, and we can get a proof of concept running and go with this. But I understand that it's on ARIN's roadmap to make this data available directly without the need for this approach.
Joe Bravo, Google. Minor nit to pick. Back on slide 3, you'd said there were only 2 elements that are uniquely identified that are used by filter generators. I know of at least one other provider's filter gen that cares about source, and you can specify the order of the source.
Absolutely.
And what I see here is you're creating a synthetic database that is just another source, so that's awesome. Thank you.
You raise an interesting point. I may have oversimplified a little bit here, but sources are relevant in some contexts. Okay, thank you for your time.
Thank you, Job.